Hi, everybody, and welcome to our second Academy Software Foundation Careers in Film and Technology webinar. We are in our second week, like I just said, today we're going to be focusing on VFX careers and software engineers in particular. We have an amazing lineup. My name is Carol Payne. I work at Netflix as an imaging specialist, and I have the pleasure of hosting you all today. So in case you missed it, last week was our first webinar where we did an overview of open source software, the Academy Software Foundation in general, and what that means to our industry of visual effects, animation, and media entertainment as a whole. So if you missed that webinar, you can go back and check that out. Just register for it the same way you registered for this webinar. And you can go back and watch that recording. There's a lot of great info there that gives a lot of context for a lot of the careers and tools that we're going to be talking about through the rest of this series. Like the slide says, I'm not going to read it, but we have lots of other webinars coming up. So they're all at the same time and same place on Zoom, and every other Thursday at 5 p.m. Pacific, 8 p.m. Eastern, or wherever you are in the world. So that is, we've got a lot of great things coming up. We'll talk a little bit more about the one after this week's at the end of today. But today we have three amazing speakers with us with different careers and backgrounds, and we're really excited to have them talk about their careers and what you can do as students to get involved in the industry via open source and other means. The first one is Bridget. Bridget Powell began her career in the film industry. She's worked in research and development and production departments for visual effects at Industrial Light and Magic, DreamWorks Animation, and Disney Animation. She really thrives on collaboration between artists and engineers. And she recently joined a company called MobileCoin in their mission to build a secure private blockchain payment system. She has a bachelor's in computer science from Georgia Tech and a master's in computer science from UC San Diego. We're really excited to have Bridget with us today. We also have Trina with us, who is a software developer. Trina Roy is a software developer at Pixar. And she's had an amazing career doing software for graduate school in scientific visualization and astrophysics. And then her focus shifted to film and animation, where she worked at PDI DreamWorks. She's worked on Shrek and Harry Potter and The Dark Knight, among many other films. She's currently a senior developer on Pixar's RenderMan team, writing tools used for the rendering of animation and visual effects seen in many of today's feature films. And lastly, we're going to hear from Karen Ruggles, who is an assistant professor of computer science at DeSales University, teaching digital art and 3D animation for over 8 years. On a personal note, Karen has been essential in making this webinar series happen, and I'm really excited to hear what great wisdom she can bring to students today on how to get involved in the industry. Karen supports her students in so many ways as director of varsity esports for her university, and really just thrives on the idea of community, storytelling, and exploring new ideas for her students and herself. And with that, the last reminder that I have is to please use, if you have any questions throughout the presentations for any of the speakers, we will have a Q&A at the end of the session once everyone has spoken. So use the Q&A box in Zoom and not the chat, so that we have a way to track the questions. But please feel free to use the chat to talk amongst yourselves, say where you're from and what brought you to this webinar today. We're really excited to get to know all of you. And with that, I am going to stop sharing my screen and invite Bridget to join me on screen. Hey, Bridget.
I also need to unmute. So I will share my screen. Let's get that going. And while this is loading, I see all the comments people chatting in from where they're from and their school. It's really cool. This is like a global thing. People from all over. All right. All right, here we go. So hi, everyone. I am Bridget Powell. So I'll be talking a little bit about my experience as a software engineer in the VFX industry. A little bit about me, my background. I went to Georgia Tech for undergrad and UC San Diego for grad school, both in computer science. And from there, I had an interesting trajectory because I actually started off in aerospace. So I was really into wanting to be an astronaut and like work at NASA. And I had a couple internships, both at JPL, which is in Pasadena, California, and the NASA Wallops Flight Facility, which is in Virginia. And then from there, once I got to grad school, I was able to get an internship at DreamWorks Animation. So from there, I worked with the animation technology team, which is a software engineering team in R&D, which is the research and development department. And they were working on developing an in-house animation tool at DreamWorks, which is still in use today. From there, I went to Disney to be a production pipeline TD. And that was more specific to working closer to the in production. So watching the film actually progress from start to finish. And then from there, I went back to DreamWorks to be more in a traditional R&D role again, and then made the switch to ILM. And then I just recently joined MobileCoin, which is in the cryptocurrencies space. So I put this slide up here to kind of encourage people to think about the fact that you can come into the film industry from anywhere, as long as you have that passion and interest in building creative tools for artists and production. And then all the skills that you do learn, you can take with you if you decide to leave the film industry, and you can always come back. So what does R&D actually do? So a lot of you may have seen these kinds of film reels that VFX studios put out. And this is, if it's not playing that well, this is on the ILM YouTube. So you can see a lot of these different behind the scenes videos on how the different departments work together. And so when we see these different layers that get wiped across in the reel, that's because there's a different department that's working on those specific elements. And then the role of the pipeline team, which is the last role that I was in at ILM, is to make sure all that data gets coordinated so that we can see everybody's great work put together as a final image. One of the other roles that R&D is also responsible for is for building specific tools for those artists to do their job in their specific department. So, and a lot of the times in order to create these like amazing images and animations that we see, the artists have to use a third-party package, in this case at Maya, or they'll build it in-house, like what DreamWorks did. So in addition to actually using that package, like Maya or Primo at DreamWorks, there also needs to be tools and plugins that get built specifically into those packages to do something specific that's specific to the pipeline at that particular studio. And that's also where software engineers and pipeline technical directors also come into building those tools. And next week, you'll learn more about what pipe TDs do if you attend that talk. So one of the things that I wanted to point out too are like some things now that you can kind of keep in the back of your mind as a student. to prepare you for a role in visual effects. And one of the things that I've learned from being a student and just growing as an engineer and as a person is to define a set of core values that describes you as a person and your values and your interests, that'll kind of guide you in your career path. So the three things for me are that I like to collaborate. I like working with artists, my other teammates, supervisors, even collaborating with your manager to talk about your career path. I'm curious, which is literally the definition of every engineer. Every engineer wants to learn about how things work. Specific to visual effects, you have to be comfortable with learning about things that are unfamiliar to you. So for us, a lot of the times, like production roles are foreign. Like I didn't take animation classes. I didn't take effects classes. So learning how those artists work and learning their workflows to be able to collaborate with them to build a tool for a specific need is something that you have to be willing to do. And also just having a can-do attitude. These movies wouldn't get made if everybody was kind of like, this is too hard. We don't want to do it. It's going to take too much time. It challenges you to think about how to solve complex problems and what do you do when you're approached with a challenging task? Do you kind of just back away from it and say, no, I don't want to do it, it's too hard? Or do you try to find an approach and a solution that works for everyone? And so this, I kind of said that learning about what your set of core values, what's important to you, what describes you as a person, really helps you be better at your job and learn to be more self-aware about what are things that you need to improve on in order to be successful, not only in a career in visual effects, but also just in life. So those are mine, but I would encourage you to just think about the same kinds of things. Like if you're working in group projects, like which person are you? Are you the type of person that leads the project? Are you the type of person that's a supporter that really just wants to help make sure everybody is doing what they need to do? Or are you kind of the person that just wants to be told what to do? So just like start to get comfortable with that. One of the biggest things that I'd point out though is that because film is a more social industry, if you're not the type of person that doesn't really like talking to people, that's fine, but it might be harder for you to get comfortable with learning how to work with other people and collaborate. And it's not impossible, but just like being aware that that is something that helps you succeed in working on projects in film. In terms of like more tactile things that you can study, Python is incredibly popular in the film industry. So and I think it's a really easy language to pick up. It's a lot easier than having to learn the rules of C++ or remember all the things that a lot of web languages are using, but which are both used as well. But Python is a great start if you haven't already learned anything about programming languages. The first bullet point, yeah, you guys are already here, so that's great. So attending all of these different talks that get you familiar with the different roles that exist is great. And if you can take an animation or visual effects class, if your school has that, I would encourage you to do it, even if you don't want to be an artist, because it gives you great perspective as to what a lot of artists are going through. Georgia Tech had an animation class that was more specific to like scripting. So it wasn't as focused on the artistic side of stuff, more so than like learning how to program different things. There was also a visual effects class there that I took too. So it was really just more to get you familiar with the process of making movies. And it also gives you a lot of sympathy for what artists go through. They do a lot of work. I kind of mentioned this earlier, but soft skills are really important in the film industry as well. Being comfortable with asking questions, I think, is the biggest the biggest thing that you can learn. And that's also something that you can learn now, like taking advantage of asking your TAs, asking your professors, clarifying questions when you don't understand, also admitting what you don't know. There was one thing that I learned as a pipeline TD is that a lot of the times it saves everyone time when you just say that you don't know something and that you're willing to find out or find somebody who does and learn from them. So there's a time and place for needing to go off and do research and to solve a problem that you're not familiar with, but there's also a time when you should just ask somebody who's more familiar with it and they can explain it to you quicker. And that moves the project along. Then once you learn how to ask questions, then explaining that same issue back to someone else also brings them along so that everybody is on the same page and understands the complex issue that you're trying to solve. And it's also an exercise in patience because everybody learns differently. But also if you're trying to explain a bug that you had to an artist who's not familiar with programming at all, that's also a really good exercise to do. And in general, just being flexible. Things change a lot in the film industry, like there are deadlines get pushed and all kinds of things. So just being flexible that even sometimes you might develop a tool that doesn't end up getting used and being okay with that is also a really big thing to learn about. And this picture I'm really proud of because Primo did win a Scientific and Technical Achievement Award, which is the equivalent of an Oscar for software projects in the film industry. And even though I specifically didn't get one, all the guys on the front did, and there are people in this picture who have won multiple ones, it's still really cool to be a part of a project that does get recognized for the impact that it has on the industry. And with that being said, that is my talk. So I hope that inspires people to want to be a software engineer in film.
Awesome. Thanks a lot, Bridget. That was really inspiring. And thanks for all the questions rolling in. Keep them coming and we will address most of them at the end. Some of them we'll answer as we go by typing, but we want to give everybody a chance to hear the answers from the speakers in their own words too. So we'll do as much as we can at the end of the presentation. And without further ado, I would like to introduce Trina. If you want to join me on screen, that would be great. Can't wait to hear what you have to say. Take it away.
Hi, everybody. Thank you, Carol, and thank you, Bridget. That was a great presentation, and I love your Bitmojis. Those are awesome. A lot of really good advice in there too. I hope we don't overlap too much. Let me share my screen. You guys, let me know if this works okay. Everybody can see my screen. Okay, hi there. My name is Trina Roy, and I am a software engineer specializing in computer graphics. And that is a pretty broad term. I'm going to move the Zoom controls out of the way. There we go. So computer graphics is a pretty broad term. So in slightly more specific terms, I write tools for artists who make movies. So pretty similar job to Bridget, actually. And usually when you are watching a film, you are engaged in the story, you're feeling the emotion, you're connecting with the characters. And hopefully if we've done our jobs right, you have no clue about all the technology that goes into making that film. But the truth of the matter is that these days, science and technology are essential to the making of these films. So I'm going to show a clip from one of my favorite Pixar films you guys might recognize. It's not just a regular clip, it's actually showing a breakdown of the progression of the scene from the first story ideas to the final rendered image. I'll play it through once with the sound so you can sort of remember the story and remember what's going on, and then I'll sort of talk over some of the sections and talk about some of the science that goes into it.
It was amazing. Just Riley and me forever. For 33 seconds.
I'm sadness.
Oh, Oh, hello. I'm Joy. So, can I just, if you could, I just want to fix that. Thanks. And that was just the beginning. Headquarters only got more crowded from there.
Very nice. Okay, looks like you got this. Very good. Oh, that's sharp turn. Ah, look out!
That's Fear. He's really good at keeping Riley safe.
Easy, easy, huh? Hi, back! Oh, we're good. We're good. Thank you. Thank you very much.
And we're back.
Here we go. All right, open.
This looks new.
Think it's safe?
What is it?
Okay, caution. There is a dangerous smell, people. Hold on, what is that?
This is disgust. She basically keeps Riley from being poisoned, physically and socially.
That is not brightly colored or shaped like a dinosaur. Hold on, guys. It's broccoli! Well, I just saved our lives. Yeah, you're welcome.
Riley, if you don't eat your dinner, you're not gonna get any dessert.
Wait, did he just say we couldn't have dessert?
That's anger. He cares very deeply about things being fair.
So that's how you want to play it, old man? No dessert? Oh, sure. We'll eat our dinner right after you eat this.
Riley, here comes an airplane.
Oh, airplane. We got an airplane, everybody.
I love that scene. That is awesome. Okay, I'm going to play it back. And I realized that, oh, you can still hear me. Can you still hear me? All right, I'm gonna play it back. And so as you're watching, double check. Okay. So as you're watching this, which, here we go. I think I'd never used a computer before. Okay, so storyboarding is how we start out. And these are all the way that we create the script for the film. And as you can see here, a lot of it is hand-drawn. And that's traditionally how it's done in, since the early days of Disney. But these days, more and more people are using software, actually drawing software, kind of stuff that you use on your iPad to digitally create those storyboards. Next stage layout, people are using modeling software to create all the elements, the characters, the sets, the props, all that kind of stuff. And even some of the placement of the elements of the set are procedural. You write a script or write a program to figure out how to throw a bunch of trees down or a bunch of big forest. And then animation is fairly, that's what most people know about. There's a lot of math that goes into creating the frames and doing the in-betweening and the interpolation between various places. And then we get into simulation, which is where my specialty, simulation and effects, are really where I've spent a lot of time. So there's a lot of math and physics that go into creating the cloth and the hair, smoke, any sort of nebulous effects, a lot of fog, atmospheric, and that type of thing. And in particular, fire. So if you look at this guy as he's walking over there, it's getting more and more angry. And then if you look above his head, you can see it kind of get sort of steamy and things are getting blurry and then starting to fire. And this is all done using physics and simulation and all sorts of fun stuff. And then final lighting is what I work on now, where mathematical equations are used to figure out literally how the light is bouncing around the scene, the light coming through the windows and through the hair. And so in general, it's using, there's pieces of software and there's there's computers, obviously there's computers, there's computer science and technology and physics throughout the making of the movie. And it's just not just in animated movies, it's, all sorts of things anything you can think of where you can apply computer graphics to it. Now, early in my career, as Carol mentioned earlier, I actually did scientific visualization. So when I was an undergrad, I went to Willamette University, and there was no computer graphics or any graphics department at all. I majored in computer science, but back in the day, I'm kind of dating myself, we kind of had to make it up on our own. And I knew I wanted to do computer graphics. And so I looked around and asked around, and apparently we had some Mars data lying around, as you do. And I decided to take that, pull it off of storage and figure out how to interpret it, write a program to look through all it's all ASCII data and sort of create images out of that. They weren't anything like the images you would see these days from from last week's trip to Mars. This was 20, 30, 40 years ago when they created this data, but it was a start. It was my first start in computer graphics. And I went to graduate school and I sort of upped the whole astronomy thing. I started working with astrophysicists and cosmologists to do visualization of relativity and cosmology simulations in what's called the cave virtual environment. So it's a big room that you essentially walk into your image. And so the image that's here on screen is a gravitational wave simulation. So it's the waves that are sort of propagating outward, and the scientists would walk in and they'd be able to move it around and explore it. And the scientists were blown away. They were able to actually see things about their data they had never been able to understand before. And that was another really a very cool way to start, because that was sort of the beginning of, hey, there's some real use for this, and I can really make a difference in I was going to say my artist, but that wasn't an artist, it was a scientist in my customer's life, so to speak. After that, I kind of deviated and I worked at SGI for a while. I did car crash simulations, I did some CAD visualization. But I also learned a lot there about software architecture, which is not a super sexy term or a super sexy, there's no visualization, there's no graphics to it, but it's hugely important for the rest of my career is to understand how software is put together. So software architecture is very different than software just coding or scripting. Software architecture is about building a system and how the pieces fit together cleanly, how it will scale when you get a lot more data or a lot more people using it. And then if you move on, how is someone else going to maintain that piece of software? And so I learned a lot at that point from my coworkers, one of who presented last week, Christina. And that was a fantastic experience. Then I got into movies. I worked on Shrek, and someone had asked about this. So it was my first movie, and I did physically based tools for Donkey's ears and Fiona's ponytail. So if you're animating hair, which is far more sophisticated these days, but back then in late 90s, early 2000s, we had our hair, they had our hair in a ponytail because it was simpler to animate that way. You couldn't really do long hair like this. So it was basically a chain, and you use physics to sort of give a hint to the animation of how that would bounce around as you move. Similarly, in King Kong, if you look closely at the New York rooftops, you'll see little scatterings of snow or the walls where there's some weathering. We use particle simulations to estimate or to approximate how snow would fall and then drift into corners with wind. And the same thing, if you look at the walls, if you threw particles at it and let them just fall down using physics, you could sort of approximate what weathering would look like on the side of an old building. For The Dark Knight, I worked on the helicopter crash where it's kind of coming down into the street and it's spinning around and crashing and rolling. That's all CG until it hits the ground. Christopher Nolan decided that once the helicopter hits the ground, it has to be real. So he actually rolled a gigantic helicopter down the streets of Chicago. But before we got to that point, that was all CG. And the car crash simulation stuff kind of helped with that as well. And so at this point, I'm kind of getting a reputation for destruction. So I worked on Harry Potter and the Order of Phoenix, Hall of Prophecy. And for this, if you haven't seen the movie, sorry, this GIF is rather gigantic over here. It's a gigantic room filled with an infinite number of shelves that are all filled with these glowing balls that are each a prophecy. And the kids are there to try to find a specific prophecy. A wand spell goes wrong, a shelf kind of gets knocked over and the domino effect kicks in and the whole thing just falls apart. So my team and I actually built the entire room and then destroyed it. So if we take a look at this same shot, the original plate, the only thing that's real in this shot are the kids, their wands, and the ball, the prophecy that Harry is holding. So if we go back, oops, the other way, that way. Everything in here is CG. So We built all the shelves. We used scripts to place groups of prophecies in different orientations to make it look random. We had smoke simulations for inside each little prophecy, so they would glow and swirl. And obviously we had destruction simulations for when things were falling over and balls were falling off, and things were crashing, smoke was coming up everywhere. I mean, nowadays you see that all the time in Michael Bay films or whatever, but that's you know, this is just one sequence, and how much went into that, you can imagine if you expand that out to an entire movie, it's a bit insane actually. So part of my point for talking about this sequence is it really involves all the skills. It involves physics, calculus, trigonometry, all sorts of algorithms, software architecture, just across the gamut. And to key on something else that Bridget said, it was a lot of collaboration, because me and one other person were focused on the actual destruction and building these up, but we had other people on the team who specializing in how that light is, that beautiful light coming from the back. And some other people were like, how on earth can we render a bazillion million balls? I mean, if you actually do each one individually, it would take years and years and years. And so we had to optimize to figure out how we could do it. So it was, you know, a lot of collaboration, working together. It was a hugely fun project, but just a little bit of inspiration there. So just some final thoughts. Big one is experiment and persist. If you know what you want to do, and then go for it and keep going and persist. But if you don't, then do not be afraid to experiment. Whether it's career-wise or whether it's on a specific tool. Like for the Harry Potter, we had all sorts of experiments of how to get things to fall over, and we had tests and tests and tests. And even one of the tests, it was just supposed to be a physics test, and they decided, hey, we like that, we're going to put that in the film. And so you never know when something you're experimenting on will sort of blossom and become bigger. And actually, I think Bridget mentioned this as well. Never underestimate the value of actually using the tools you write. And speaking the language of your users. So if you're kind of in your own world and you think, I'm going to write this tool and this is what the controls that need to be on it, and then an artist sits down to use it and they don't think like you, and so it's not solving their problem. But if you actually are actively using the tool and can really understand what they're talking about, it makes that communication a whole lot easier. And that can be whether you're writing an app for your phone or whether you're writing a gigantic piece of software for, holoprophecy or something. And finally, none of this is easy. I mean, I've done some really cool stuff in my career, but there have been struggles along the way. And there always will be, no matter, how easy you think it's going to be. There's always going to be a point where something goes wrong or you're getting down. And I can only say, just hang in there and find a mentor and find someone who will help you through those rough times and guide you. And then once you get past that, and when you feel comfortable enough, you can turn around and be a mentor. And that is also just as helpful, to have a sounding board and to help someone else, help the next generation. So that's about it. Thank you for listening to me. I appreciate it. And I look forward to having some questions.
Awesome. Thanks a ton, Trina. That was really great. Just seeing all those visuals along with it really gives you a new perspective of everything that goes into making one frame of a movie or a TV show or a video game come to life. And it's really just, every time I see it, it's crazy. But we have one more speaker, Karen Ruggles, who I'm really excited to have speak to all of you, because tons of the questions that are pouring in the Q&A, and keep them coming, really, Karen's going to dig into a little bit of, like, it's intimidating. How do you get started? Where do I even look? Who do I even talk to? And that's, I want to make sure you all know that this is the place that you start asking those questions and starting to get those answers. And hopefully we can provide you with a path forward and next steps. And Karen is going to talk a little bit more about that. So take it away.
Thank you. And thank you to all of you guys for coming tonight. I just have a short presentation, then we're going to kick it off to Q&A. But my whole thing is on actionable steps. So how can you follow your path? And if I can get everything situated here, I'm going to go ahead and share my screen. And here we go. Great. All right. So starting out here, part of what I'm really excited about tonight is just sharing the stage with Trina and Bridget and Carol, obviously, and all of our workers behind the scenes that are not pointing out here to you on the panel. But this has been an immense effort to bring this forward to you. So hopefully you're making the most of these opportunities and this webinar series so that you can learn and eventually follow your path. You might be listening tonight and thinking, software engineer, wow, that sounds like me. I want to be Trina. I want to be Bridget. And you would not be wrong. Of course, you want to be these people. But you might also be listening to that and say, oh, well, that doesn't really sound like me. Maybe I'm more of an artist or a modeler. And that's absolutely fine. I think most of what you need to do is define what you are as much as what you're not. And really that comes down to actionable steps that we can take a look at today. So now that you are starting to define a goal, how can you actually walk towards that? And what does that even look like? So let's go together. So the first one probably isn't a surprise to you, and that's work hard. We learned about some skills. Bridget mentioned C++, some Python being, really good skills, but many of you were probably surprised that there weren't that many technical skills listed, and most of the skills needed to be successful are more on the soft skills, right? Being a good communicator, talking to people who don't really speak your language in the form of your technical and their artistic, or your artistic and their technical. So how can you find that common ground? So speaking to as many people as possible to try to find a way to communicate. And that's really important, as well as the technical skills. So obviously developing those skills and, attending talks like this to fill in the blank. So if you do want to be that software engineer and Python is important to that destination, and maybe your Python is rusty or you've never heard of Python before tonight, well, great, that's on your task list. Now you are learning Python. So these are the types of things, as you start to go to talks, fill in the blanks for yourself to say, that's where I want to go. And these are the skills that are going to get me there. So that can be an actionable step for you to start your journey towards your path. The second one is time management. So this is as much about meeting deadlines, not procrastinating, knowing yourself and knowing that you will procrastinate, and trying to find a balance. It is also important, and I do so hope that you hear me when I say this, that balance is so important. Make sure that you're making time for yourself. Go for a walk in the woods. That can be just as inspiring and really open up your mind to solve that next problem, the physics simulation that just won't get solved. So having that balance is really, really important. And, as we've heard from some of the other speakers tonight, to explore the things that work for you. So for me, making lists, having deadlines, having my calendar intact on my computer and my phone is really helpful for me, but that might not work for you. So ask people what works for them and try it out yourself until you find something that works for you. And that can help you avoid procrastination and really meet the deadlines that help you succeed toward your goal. We heard this previously, but also be open to feedback. Every single person that have talked here tonight that you will ever talk to has to work on something. And this whole idea is just about honing your craft. And, you can kind of think of it like if you, if you peak, right, then you're on the decline. So if you're not honing your craft and you don't have anything left to learn, then you're probably declining. So always be learning and always be honing your craft. In addition to that, this industry changes so frequently. So you have to be up for the challenge and you have to be ready to learn at a moment's notice. And that's one of the things that's actually really fun about this industry. So being curious, as Bridget mentioned, that's what draws us to this industry. So keep learning and keep exploring and don't be afraid of that feedback. It's only going to make you better. So that's our work hard column. Our second column here is more about opportunities. And both of our speakers tonight spoke about opportunities. Oftentimes, and I teach at the undergraduate level, so oftentimes I hear my students talk about, well, they can't make that film because their computer is, old and clunky, or they don't have the right camera, or they don't have the right software, or they don't have time, right? So all of these are barriers that are being placed in front of us and making that chasm to our goal that much wider. So don't wait, find a way. Part of what we do is creative. So how can you solve the problem in front of you, given the tools that you have? Don't let the story, wait, if you can just persist. So find a way. I always think of this one, so you hear networking all of the time. And actually, as a young person, I hated this advice. I thought it was so disingenuous to be thrown into a mixer or like a networking event and be forced into conversations. And I actually avoided them in most cases. So, there is worth and value to those type of instances. So don't shy away from them. Even if you do feel like you're a little bit more of an introvert, that's totally fine. You still can communicate in your own way. You don't have to be that bubbly, outgoing person in order to be successful. You just need to find the way that communicates best with the community around you. And part of that is networking, but really what we're talking about when we talk about networking is finding your community, right? And we talked, and we'll hear a little bit more tonight about the ASWF Slack channel. So, Slack is sort of like Discord or, a messaging app that you can get on and talk to other people who are like you. So you might already have this type of community in, your neighborhood. Maybe it's your classes or your group of friends. But really what you should be looking for in that community are people who can help encourage you, right? Challenge you and give you feedback and hold you accountable. Developing those types of relationships that will keep grinding your skills to be better and better every single day, right? And we talked a little bit about finding a mentor, which can be daunting, right? Just to say, go find a mentor. You're like, well, where do I even start? Part of that is your community, right? Find the communities, and through that, you'll start to see people who sort of align with your pathway. You say, wow, I could learn a lot from that person, and I feel comfortable with them. A mentor should be someone who you get advice from, that you trust, but also holds you accountable and is able to give you critical feedback, but also lift you up, right? You don't want to have someone who's just, tearing you down all of the time, someone who believes in you. And that's really critical for that community, to make sure that you're pushing past all of the negativity that will come with being an artist or being a programmer, facing challenges. So, find that community. And it's fine to test it out. Go to your classes, find that. If it doesn't have those three things, then, maybe branch off to another location so that you can grow. And the last one under our opportunities here is ask questions. We already heard this. I think Bridget said it in like her first slide. So what's really wonderful about being a student is you have a free license to ask questions. So please do. Most of your teachers want to hear your questions. And if you don't know what to say, you can start with some easy softball questions like, what projects are you working on right now, professor or teacher or whomever, right? Whoever's in front of you can give you advice. There's something inside of them that you do not have. So engage that person, and with some common ground. Everybody's working on something. Everybody's inspired by something. So what fascinates you right now? And that can start a conversation that can make you a better artist or a better programmer. So what interests you? What fascinates you? What's the next big thing in your industry? Those are all really easy questions to grab hold of and use in your arsenal, just to start being comfortable talking to people in a community and, building that community yourself, being active in that space. And our third and final little column here is please be true to yourself. This one's going to get a little mushy, but you'll be fine. You'll be fine. So the first part here is self-reflection. I'm sure I can't see chat right now, but I'm sure the chat is blowing up with some of my students being like, of course she's saying this, because it is so true. It's important to take time to be quiet with yourself and just listen and assess the things that have happened. Maybe it's during the day or during the week, things that work for you or didn't work for you, and why. Why did that work for me? And then through that self-reflection, you can say, when I'm in this certain situation, I'm able to succeed. But when I'm in this situation, it's not really working for me. So really what you're trying to do in those quiet moments is find the things that work for you and build around those, and maybe get rid of some of the things that aren't really helping you. So that self-reflection is so important, to just be able to be strong with yourself and take those quiet moments to meditate or whatever you want to call it. Just be comfortable with yourself and ask yourself tough questions about how things are going, and allow yourself to be honest with yourself and be nice to yourself. It's okay to think and not be sure. Part of what's really beautiful about being human is having our own minds and really starting to understand them. And as a student, you'll grow into that, which is really, really exciting and why I love being a teacher. The next part here, and we're almost done, I promise, is know yourself. This will come out of self-reflection. But I do want to say with all of my heart, I know that, I don't know all of you on screen, but you are bright and you are beautiful, and celebrate yourself. There's so much to you that you can bring to this world. And, it's hard to be an artist. It's hard to be in this field, but it's beautiful. And you are here, right? You're here tonight trying to celebrate that part of yourself. Something drew you here tonight to do that. And I hope that that will progress and really make you comfortable in your skin, so that you can just continue to thrive in this industry. And the last one, I swear I didn't, steal this from Bridget. I saw the same thing and I went, oh no, but core values, right? So these three things will lead you to your core values. And that can help you understand, if you're starting to deviate down the path you go through, your self-reflection, you think, well, gosh, this isn't really who I am or where I need to be, then you can correct the ship and get back onto the path that's important for you. And that's really what everything is all about, is to make sure that this community and all of these things are working together to put you in the best possible location, and, enjoy the journey while it continues. So in conclusion, these are my advice to you as you start to think about who am I going to be and what does this mean to me? Learn as much as you can and make the most of your opportunities, and please be true to yourself. Thank you.
Awesome. Thanks a ton, Karen. I am real quick going to share my screen again before we get back into the Q&A. And there we go. Because I just want to point out a couple things. And we mentioned it in the chat already, but check in with us, communicate with us, stay in touch, either through our mailing list or through Slack or through both. We're active on all channels. Ask your questions and get them answered there. And then make sure to join us for the rest of the series. We have a great webinar coming up in 2 weeks, March 18th. We'll have Mallory King from Apple, Tracy Priest from Blue Sky Studios, and Jennifer, who's been active in the chat, Furby Creamer, who is from University of Florida and has been another essential person in getting these webinars off the ground. So come back in 2 weeks to talk with them. And that's all I'm going to say. I'm going to speed through this because we want to have some time for Q&A. So I will now stop sharing my screen again and ask all of our speakers to come back on screen so that we can have a little bit of a discussion. Great. There's Bridget. Cool. So there's a ton of questions in the Q&A, but I'm pulling out some common themes from them. And one of the most common is, what is applying for an entry-level job in a technical field in our industry, like what skills are they looking for? And some of this is already covered, but people are wondering if you need to have a demo reel for a technical role, or what's an entry-level like coding tests that they might give you. And I know that those vary a lot from company to company, but if there's any advice that Bridget or Trina that you have of how to prepare and how to know just, what to look for, that would be awesome.
Yeah, in my experience, demo reels aren't usually used for engineering positions for R&D. I know Bridget may have a different take. I think it sounds like we've worked in a good overlap of companies, but different. As far as skills and stuff for entry level, just really solid knowledge of programming and C++ and Python are huge. I don't know what else, Bridget, can you think of other than sort of those obvious pieces?
Yeah. Oh, sorry. Okay. Yeah. Unmuted. Yeah. I think what Trina says is right. I have never had to do a demo reel. I think it's interesting when people have it, like if you want to work on the renderer or one of the particle simulation system and you want to like kind of show off this thing that you did in college. I think it's interesting, but it's never really been a requirement.
Yeah, if you have a specialty that you're aiming for and you have something that shows that off, I mean, it's kind of weird to bring in code, but you can bring in your laptop and show off what you did and then be able to explain all the pieces of it, the architecture of it and all that kind of stuff. Inevitably, you're going to be asked, what were your challenges? What was hard to do about this? And to be able to really discuss that honestly and say, yeah, this part really sucked. I had a really hard time with this and what you did to solve it.
Yeah, exactly. I was just about to say that too, is that it's more important, I think, at least for every position that I've interviewed at DreamWorks and Disney and ILM too, to talk about the project that you have done. So just like highlighting it on your resume or something, and then be able to talk through those things, like what was your contribution? What did you like about working on this project? What was hard? What challenges you encountered? What technologies did you use? And that kind of thing.
Exactly.
And a lot of the other thing that's a little bit similar is that Disney's apprenticeship kind of program, I forget the name of it, that they had was the program that I participated in as a pipeline TD. And that was really the intro to learning about the different parts of the pipeline. And they have like different roles so you could join as like an entry-level artist, as an animator or as a lighter or a layout artist or something. And then they also had one for pipeline TDs. And depending on what role you were in, the pipeline TDs didn't really have to have a reel, but the more artistic roles did. But either way, you still kind of learned about the different departments and what each department does and what your role was as a pipeline TD in support.
There's also, similar to that, there's also Khan Academy, something called Pixar in a Box, where they actually have little clips, maybe 5-10 minutes, of a lighting artist, a layout artist, a storyboard artist, and they go through a day in the life of and show some detailed elements of what each part of the pipeline is and what it involves, and it's fantastic. It's on Khan's K-A-H-N if you're not familiar with it, but go check it out. Pixar in a Box.
Yeah, those are all great things. And the other thing that when I think about this is just like, entry level, you just want to get in and learn. And so, you think about those entry level positions as like, take what experience you have and just interview, do the best you can, get experience in interviewing. We talk, at the ASWF, work on an open source project, try committing, try checking out some code, making some changes, doing some things, having that as, you've contributed to an open source project is something you can put on your resume when applying for technical jobs. So that's another thing.
And the name of the program is the Talent Development Program at Disney Animation. So if you go on their careers website, I highly encourage everyone to look at it because it was a fantastic program. It was a lot of fun.
There's another couple questions around people from really like diverse and unique backgrounds. So maybe people that aren't majoring in computer science or engineering or something like that, still going into a technical field or wanting to go into a technical field in our industry. Do you have any advice for them? And how much of that do you see? Do you see most people, working at these big studios with PhDs, or is it super varied?
Yeah, I don't see a lot of PhDs unless it's something specific, like the whole facial capture system that that worked on what's the last Netflix movie? I Heard You Paint Houses.
The Irishman, yeah.
The Irishman, yeah, that was the book. That's the book name. So yeah, that was like a whole like research study that a lot of the people that worked on it did have a more PhD focused background, but most of the roles you don't have a PhD in it, in anything.
Yeah, I'm on the RenderMan team, and there are a few PhDs, but they're super hardcore specialized. And it's interesting. This came up in a thread with some women at Pixar, and they said, "What was your major, and what do you do now?" And there's everything from like, I was an anthropology, and I'm now a systems engineer, and I studied architecture, and I'm a technical director. And so it's not a requirement, and it really is, you can find your way there regardless of what your background is, if you sort of have the passion and the persistence, and it's definitely not a requirement.
Yeah, the common foundation to everything is the programming side of stuff. So if you could pick it up, if you're not already a CS major, pick it up on your own, or just start from somewhere.
Yeah, make an iPhone app.
Yeah, and you guys have mentioned a couple resources already to sort of pick it up on your own. Do you have any others off the top of your head that you'd also throw out there?
Code.org has some really good sort of basic learning. I mean, I think it's geared for younger kids, but it's also like very visual way of learning how to code. So it's super beginner, but it's a great start.
Yeah, I think is that the same as Code Academy?
No.
Yeah, I think there's a separate one called Code Academy.
Code Academy.
That does the same kind of thing. Yeah.
I learned that a lot of the, when you're going to get back into it, and I got back into Python, I learned Python the hard way, which I find was a hilarious name, but it works too. So for Python specifically, there's that one.
That's awesome.
There's a lot of questions too in the more like when you're talking about, knowing the artist side of the work for the tools that you're creating. People are asking what programs they should specifically look at, and we all have different kind of opinions on this, but what's your philosophy when you're trying to like put yourself in an artist's shoes?
The easiest way for me is to literally go ask them. It's easy to say when you're on the job, is like if they're trying to do something that, because there's a lot of tools within Maya, which is a 3D content packaging program for creating assets and stuff. And there's a lot of stuff in there that I don't know how to do. So a lot of it is literally walking to their desk and asking them to show me what are the steps that you're doing right now, and to see like, why is it so hard? Because otherwise they're suggesting this new way of doing something for a reason. So like literally watching them click this menu and then click over here and like see how many clicks there's going on is really helpful to me. But as a student, I think even still trying to do like a basic Maya class in the same way that you pick up coding is also really helpful, unless your school has it. Because in my case, Georgia Tech had the class, so that's how I picked up Maya. But there are some like intro animation courses that do the same kind of thing, and no one's expecting you to be like a world famous like animator out of this, unless you really want to do that. But at least like navigating around it and understanding the different modes that exist in the program, I think is really helpful.
Yeah, I think same. If you do, just sit side by side with an artist, and even just sit back and watch them, and because they get into the zone and they start working, and they've got their ways of doing things. But sometimes it'll take someone 5 or 6 clicks to do something that you can do with just one button kind of stuff. And the other thing is to actually like do the task that they're trying to do, and figure out how to do it from an artist's perspective. And that's usually very illuminating because it's usually not what you expect. So
yeah. And then I think we only have time for probably one more, but I wanted to throw in to Karen for those that, are confused between, picking computer science or electrical engineering, or what's the difference between software engineering and computer science, and what if my school doesn't have any of these degree programs? Do you have advice for students looking to still get involved or to make the most out of their time in school?
Absolutely. Yeah. I think, most schools do have a computer science presence, whether it's a major or minor or what have you. So you can definitely speak to somebody, a faculty member in that space. You might even have a computer science club at your school, or a coding club or something along those lines. So you can join that club and learn from those students as well as from the faculty members. And it's okay if you're at the school and you don't belong to that, or if you've never taken the class. I'm a faculty member. I love meeting students that are outside of my discipline. So just look up, shoot them an email, or, stop by their office if you are in person, and see what their office hours are and say, hey, I went to this talk. I'm excited. What do I do? And that's what we're here for, to answer those questions for students and to connect those bridges. So part of it is, participating in these types of talks, but also trying to make the most of the opportunities that you have, whether it's at school, right? And, even high schools, some of the high schools might have a computer science presence, and you can learn from online as well. Do be careful with some online. That we got some really good suggestions here, but diving into YouTube sometimes can teach you bad habits. So just be careful that you're learning the right way. And part of that will be with that community that I mentioned. So you could even, part of it is just getting a project, right? Try to do a project, learn through a project, and that can be very rewarding as well as frustrating, and it will get faster as you start to learn.
Cool. That's great.
Yeah, I wanted to add really quick is to what Karen is saying is, take advantage of asking, like joining a research lab at your school. If there's a computer graphics one, is like the greatest way to do it. Because when I was like a first or second year, I also did the same thing. And you can even ask your professor, is there like a small project or something that I could work on that would help contribute to whatever other existing research is already there? That's also a really great way to learn.
The lab that I was in graduate school was actually half artists and half engineers. And so it was a great way to sort of get that person. We were working side by side doing projects. And so that was not only a great way to learn, but it was also, it's a lifetime of community is now. That's how I got into film. It's because I knew these artists who ended up going to LM. And so making those connections.
You make great connections there too. And if you don't have something like that at your school, or you're in a smaller school, even one or two people that you find that have an interest in the same thing as you do, and one of them is an animator maybe and wants to be an animator, so they animate and you make tools and you share the work and you do a group project and you just make it happen. So I think that I agree that learning that way has been some of the most productive time in my education. Is just like trying to make something. There's tons. Go ahead, Karen.
Oh, sorry. I would also add that those types of experiences shine through during an interview process, right? So a lot of times during interviews, if you say, oh, I took a coding course, versus I, engaged out of this class with 3 other people, one was an animator, I was trying to learn code, and like demonstrate that you had a problem, how you approached it, and what the solution was. And through that type of communication, not only does your passion show through to the person who's interviewing you, but you also have a practical experience of bringing that together. Because if you're a computer science major, you're required to take this course, right? So it's not specifically a surprise that you took a Python course, but if you went out of your way to try to, create something, and through a club or what have you, you can demonstrate your passion as well as your ability to work within a team. And those are two things that, will make you stand out in that interview process versus everyone else who has taken Python 101 and, all of the other courses that are required. But this is an experience and this is a story that you can tell during that interview process.
That's awesome. We are a little bit over time. I know there's tons of other questions. So please, if you didn't get your question answered or you'd like more info, join us on Slack or the mailing list, and we will get your questions routed. to the right place, and we've got lots of amazing people in there to answer. And join us for the rest of the webinar series where lots of other people with different career paths and different choices, and then different ways of how they ended up where they are going to talk with us over the next couple months. So hope to see you guys soon, and have a lovely rest of your day or evening or middle of the night, depending on where you're located. Bye, everyone.
Bye-bye.